Okay, here we are, kids. All right, here we are. Here we are. It's a Friday where you are. It's a Wednesday night where I am. It's Wednesday about 7:30. Why am I doing this on Wednesday? To show you on Friday. I'm talking to period A right now. So it's very confusing. I'll share the screen and help you. But you know what else is confusing to me? Look at this shirt. What are these? Can you see that? Well, you look at that. What are these holes for there? You stick your thumbs through? I don't get it. I don't know how to use a camera. See the holes? Can't see the holes. See those little holes right there? I don't know. Is it to do this? Is it to keep my palms warm? I don't really know what the function of those holes in my shirt are, but that's not your problem, is it? All right, let's share a screen, see where we are mathematically. All right, so if you're period A, here we go. Well, yesterday, Thursday in class, maybe we had a test. If we did, fine, we'll get it back when I see you next and we'll move on from there. But maybe we didn't have the test. As I speak, I don't know if we did or not, because a couple people came to me today, Wednesday, during advisory and said, I'm not sure we're quite ready. And these are good people. Well, you're all good people, but these are people who are doing great in class. I know they're not just trying to goof off and get more time. They really want to do well. So maybe we had the test yesterday. If so, great. Well, maybe we didn't, and I gave you more practice. If that's the case, we move on to today, Friday. I'm out. That's why it's the video. I'm out, so I'm giving you a video on a new topic, trig functions. Not on the review for the test. We're done with that. Trig functions. And your homework is going to be this. So make a note, that's your homework. Worksheet, page 167, 1 through 12. Where's that worksheet? I'll show you. Let's get this up here. That's not what I wanted. Maybe it's here. I'm looking for Google Classroom. Oh, there it is. All right, in Google Classroom. Here's your Google Classroom. Right at the top, I put this bunch of worksheets. There were some worksheets like this before, but this is a different group. So as we go into there and you open it up, oh, I'm not sharing the screen, am I? Idiot. Start over, share screen. Share screen, here we are. We're in Google Classroom. This is your Google Classroom. And I put at the top of the announcements, these worksheets. Okay, so you open the worksheets. You can go to page 167. It's going to be in the bottom. What are you doing? The page number is on the bottom is what I'm trying to say. Let's try it again. That's in the way. Scroll down to page 167. Hey, pretty good guess, right? There it is. All right, so go by the number on the bottom, page 167. So it's this tricky stuff. All right. So let's go back to this. Oh, idiot. Let's go back to this. All right, so that's your homework. That's what I'm going to teach you right now. Now, if we didn't have the test Thursday, you'll be having it Monday. But you say, wait, Monday is going to be usually a video day. Well, to avoid having video days Friday and Monday and then dropping Tuesday and pushing the test to Wednesday, I'm going to come into school. I will come into school in person on Monday. So go to the classroom. Don't go to the CAF, go to the classroom, and I will administer the test. So if we didn't have the test yesterday, you have the test on Monday. And we go from there. Okay, that's confusing, but just show up to class and you'll be fine. All right, so let me show you the new topic. It's trigonometry. All right. All right, trigonometry is all about the relationships. Oh, what is that? The relationships and the sides of a right triangle. So, oh, I know. So let's take a right triangle here. It's a perfectly good right triangle with the right angle. Okay, this angle here is called theta. Theta, it's pronounced theta, theta. And we have obviously three sides, and one side's called the hypotenuse. You know that from geometry. This is the hypotenuse. It's the side opposite the right angle. Opposite the right angle is the hypotenuse. Then the other two sides we're going to call opposite or adjacent. Well, which side's opposite, which side's adjacent? Well, it depends on the angle we're talking about. For this angle here, the opposite side is here. And the adjacent side to it would be there. So for this particular angle we're talking about, the opposite side is there. The adjacent side, adjacent means next to, doesn't it? Is right there. Hypotenuse is always opposite the right angle. If we're talking about a different angle, though, if we're talking about calling this angle theta, well, now this is still the hypotenuse, opposite the right angle always. But now this would be the opposite, and this would be the adjacent, because opposite is the side that does not connect. In other words, this angle is formed by this side and this side, right? This angle is formed by those two sides. Which side did not get involved in that forming that angle? The opposite, because he's oppositional. He doesn't want to play along and form this angle. Opposite is oppositional. Adjacent is next to. Okay, so no matter which angle we're talking about, we have our opposite and adjacent. Go back to this. Okay. Well, we're going to look at relationships between these sides by making a fraction of the two sides. We can put the adjacent side over the opposite side, and that's a fraction. We can put the opposite over the hypotenuse, and that's a fraction. For example, let's say this side was 3, and this was 4, and by Pythagorean theorem, this turns out to be 5. So we get these ratios, these fractions. 5 over 4 is a ratio, 3 over 4 is a ratio, 3 over 5 is a ratio, and so on. Well, there are 6 such ratios. And here's the first 3. The first one's called sine. It says sin, but it's an abbreviation for the word sine. So sine of an angle is defined as the opposite over the hypotenuse. So in this case, the sine of this angle theta is the opposite 4 over the hypotenuse 5. So the sine of this particular angle would be 4/5. COS, cos, is short for cosine. Sine, cosine. Cosine is adjacent over hypotenuse. So in this case, the cosine adjacent is 3 over hypotenuse 5. And then TAN is short for tangent. And tangent is opposite over adjacent. Opposite 4 over adjacent 3. There are 3 more trig functions. I'll get to those another day, but for right now, let's focus on these 3. So make sure you have these definitions. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So the first thing we're going to do is take a right triangle. Oh, it's buried under there. Take a right triangle. And let's say we're going to talk about this angle. The angle could be theta, could be x, could be a, whatever. Let's say this angle. And let's say this side is 12, and this side's 5. And you say, wait a minute, that one doesn't look short, long. Don't worry about that. Okay. And the question is to find the trig functions. We want to find sine of theta, cosine theta, and tangent theta. Well, in order to do that, we need to know all 3 sides, because we need to know the adjacent number, the opposite number, and the hypotenuse number. They only give us 2. Well, remember your friend Pythagoras? Pythagorean theorem? A squared plus b squared equals c squared. Let's use that. C is always the hypotenuse, so that's what we're solving for. So we have 5 squared plus 12 squared equals c squared. Remember, it's leg squared plus leg squared equals hypotenuse squared. So that's 25 plus 144 equals c squared. That's 169 equals c squared. Take the square root of each side, c equals 13. So c is 13. That's called the Pythagorean triple. 5, 12, 13 is called the Pythagorean triple because it works in the Pythagorean theorem. I don't know why that widget thing happens. I don't know how to fix it. That's the end of the lesson. Okay. Goodbye, widgets. I can't do it. It's gone. Okay. So given that, here we go. Sine for this angle is opposite 5 over hypotenuse 13. Cosine adjacent over hypotenuse 12 over 13. And tangent is opposite over adjacent 5 over 12. So you really need to memorize these, kids. I hate to do this, but a lot of teachers teach this. SOHCAHTOA. SOHCAHTOA. You can say there's a Native American legend that goes along with all this. King SOHCAHTOA, Chief SOHCAHTOA, whatever. I don't want to get into that, but here's what it is. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So you can remember it that way if you want. All right, let's do another one. Another right triangle. And let's say on this one, we'll use this for the angle. We'll call the angle X. And let's say this is 6 and this is 4. We want to find sine X, cosine X, tangent X. All right, well, we get, for this angle, we get the opposite, we get the adjacent, we don't have the hypotenuse again. So a squared plus b squared equals c squared. 36 plus 16. So 52 equals c squared. Take the square root. It's square root of 52. And square root of 52 breaks down to be 2 square root of 13. 2 root 13. How do I get that? 52 breaks down to 2 times 26. That's 2 times 13. The sock drawer, pull out a 2, 13's inside. All right, so now you get the 3 sides. So sine is opposite 4 over hypotenuse 2 root 13. Cosine's adjacent 6 over 2 root 13. And tangent is opposite over adjacent 4 over 6. Okay, nicely done, kids. Way to go. Except, can I get that out of there? Except all 3 of these got to be reduced. Let's give ourselves some room here. Oh, didn't mean to do that. It's gone. Oh, no. Oh, no. Well, here's what we had. I remember we had tangent was 4 over 6. Tangent X was 4 over 6. Sine of X was 4 over 2 root 13. And cosine of X was 6 over 2 root 13. Well, tangent's easy one. That one just reduces to 2/3. So we're done there. Sine, well, 4 over 2 can reduce like this. Right, the 2 and the 4 reduce. We can't leave 13 in the denominator. So remember this move, you rationalize the denominator. 2 root 13 over 13. Oh, my aching back. 2 root 13 over 13, right? Square root of 13 times square root of 13 is 13. How about cosine? We had 6 over 2 root 13. 2 and the 6 cancel. So I get 3 over root 13. And you go top and bottom by root 13. 3 root 13 over 13. All right, so you need to try one on your own. So here's your right triangle. And now let's give you 12, 8. Let's call that angle X. And now you got to find this missing side. It's one of the legs. Let's call it B. So Pythagorean theorem. That's the hypotenuse. So that's the one that stands alone. So it could be 8 squared plus b squared equals 12 squared, 64 plus b squared equals 144. Subtract 64 from each side. So b is going to be the square root of 80, which breaks down into 4 root 5. I'll let you figure that one out. It's 4 root 5. Okay, there are 3 sides. So go ahead and create your trig functions. Sine of x, opposite over hypotenuse. Cosine x, adjacent over hypotenuse, and tangent opposite over adjacent. These are easy because the square root's in the numerator, so you don't have to rationalize, just reduce 4 over 12. So you get square root of 5 over 3. That's 2/3, and that's square root of 5 over 2. And those are your 3 answers. All right, so let's look at the homework. That's not the one I want to look at. Here we go. It says find the 6 trig functions. We're just going to find 3, sine, cosine, and tangent. All right, so if you look at, this is actually page 167. I'm going to go to 168. If you look at these, they're exact same thing. You're going to start off by using Pythagorean theorem to find the missing sine. Find the hypotenuse there. Here you're finding a leg. Here you're finding hypotenuse. So a squared plus b squared equals c squared. Whatever you get, then you form your sine, cosine, tangent. Okay? That's those. Look at these ones. It says in the right triangle, angle A and angle B are acute. Okay? So you have a right triangle. Made it like that. You get a right triangle. Angle A and angle B are acute. So that means angle A, angle B. Let's call the hypotenuse angle C. It's got to have a one right triangle. And if A and B are acute, they're less than 90. So they have to be those two. All right. If tangent B equals 2, they're asking what's cosine B. All right, so kind of working backwards. We know tangent is what? Opposite over adjacent. Well, if tangent B is opposite over adjacent, it equals 2. That's really 2 over 1. So that tells us our opposite side is 2 and our adjacent side is 1. So for angle B, its opposite side is 2, its adjacent side is 1. There we go. See how we did that? Tangent B is 2, make it a fraction, 2 over 1. Tangent's opposite over adjacent, so it means opposite is 2 and adjacent is 1 for this angle B. Opposite's 2, adjacent 1. So how do you find cosine? Well, cosine is adjacent over hypotenuse. We know adjacent's 1. We don't know the hypotenuse, but you do Pythagorean theorem and you'll get root 5. 1 squared plus 2 squared equals c squared. So it's 1 over root 5, which is root 5 over 5. That's that one. Let's do another one. Number 5 says if tangent A equals 11 over 17. Okay, well, we know again, tangent is opposite over adjacent. So that means we can say opposite is 11. Was this A? This is B? Well, either way, but if we call that A, its opposite is 11 and its adjacent is 17. Well, they ask, what is sine A? Well, sine is opposite over hypotenuse. Well, we know the opposite is 11. The hypotenuse, we got to figure out by Pythagorean theorem. I actually don't know what it is. You got to do 17 squared plus 11 squared equals c squared. 289 plus 121, whatever that comes up to be. And that's what goes in there. Okay. So that's how you do that set. How about these ones? Okay, it says use a trig function to find each value of x, round to the nearest tenth. All right, so a little different here. we have an angle, a side, and an unknown side. Over here, we have an angle, a side, an unknown side, and same thing over here. So there are three players. 1, 2, 3. I call this a three-player game. For those three players, we have to decide which trig function is at play here. Well, for the angle 30, what sides do we have? I have the opposite. If angle 30, that's the adjacent, isn't it? What uses opposite, adjacent, tangent? So tangent of angle of 30 degrees is going to be the opposite x over the adjacent 7. Let me go through that again. In each case here, there's going to be three players, I call them. 2 are going to be known and 1's unknown. You have to look at the relationship to see if it's a tangent, a sine, or a cosine. Here's how we do it. For this angle, that's opposite, right? That's the opposite. And for this angle, that's the adjacent. Who uses opposite and adjacent? Tangent. So tangent of what? Always need an angle. Tangent of the angle equals opposite x over adjacent 7. We're trying to solve for x, trying to find x. So here's what you do. You use your calculator to find tangent of 30. Oh, we're not supposed to use our phone, but I got my phone. We know if we turn the calculator that way, I'll have to show you in class. That didn't work. Turn the calculator sideways. Come on, calculator sideways. That must be locked. But anyway, if you turn it sideways, you get the trig functions. And all you do is you type in 30 and then hit tangent. And it's going to give you a number. I really should do this for you. So hang on, don't go away. Okay, so it might look like that. Same thing on your Chromebook. So for this, I'm going to hit 30, and then I hit tan, and it says 0.5774 equals x over 7. How do I solve that? 0.5774 equals x over 7. To solve for x, multiply it side by 7. Those cancel. So x equals, just do that out, 7 times that. So whatever you get, 3.6 or something like that. Okay. Let's do another one. Let's look at number 8. All right, what do we got here? For these three players, for this angle, that's the opposite. And that's the adjacent. So it looks like opposite, adjacent, tangent again. So you write tangent 20 equals the opposite x over the adjacent 32. Almost the same thing as before. So I can hit 20, then tangent, get the number, or I can do this first. I can multiply by 32 first. Those will cancel, and I'll be left over here with x equals 32 tangent 20. And you can just type it in like that in your calculator. Hit 20, then tangent, then times 32. So I'll do that. I get 20, then times tangent, then times 32. And I get 11.64, and it says round to the nearest tenth, 11.6. Let's try another one. I don't like this one. Let's change number 9. Let's say that's not the 17. Let's say 17 is put there. Okay. So for this problem, for this angle, what have I got? I've got adjacent, and that's the hypotenuse. How do you know? It's opposite the right angle. So what's adjacent hypotenuse? Cosine. So you write cosine 49 equals adjacent x over hypotenuse 17. To solve for x, I'll multiply each side by 17. So x equals, I just punch in 49 cosine times 17 and get your answer. And that's how that works, kids. 10, 11, and 12 here, I think are the same. Oh, no, they're not. So I don't want to do those. Let's go back to actual page 167. So page 167, we already looked at how to do those. And this is what I just did with you. So let's do one of these and we'll be done. How about number 7? So for number 7, you identify the angle and what sides do you have? Adjacent and hypotenuse. So the first thing you're going to do is identify the sides of the angles. It's like number 10. For that angle, that's adjacent and that's hypotenuse. For number 8, for this angle, that's opposite and that's hypotenuse. So opposite hypotenuse is sine. Adjacent hypotenuse is cosine, and so on. So number 7 is going to be cosine because it's adjacent hypotenuse. So cosine of an angle, always need to put an angle. Just the letters cosine mean nothing, and you have to have an angle in there, x or a or 60, equals adjacent 5 over hypotenuse x. Well, now we have the x on the bottom. That's okay. Here's how I'd solve this. Multiply each side by x. Those x's will cancel. So have x cosine 60 equals 5. And now to get x by itself, divide by cosine 60. Cosine 60 is just a number. So what do I get? X equals 5 divided by cosine 60. You have to just punch that out. Okay? All right, that's all I got. We've done this long enough. I know you'll have questions on this, but let's take care of the test first and we're good here. All right, I'll post this. All right, kids, it's Friday. Have a good weekend, I guess. Bye-bye. Oh, here we are again. Bye-bye. Bye-bye. Trying to end.